cycle, we were graphing quadratics, the parabolas,
I
the
gotta
U-shaped
mess
graphs.
with that at lunch.
We were graphing them in standard form. So we had to find negative b over 2a, and then we had to plug it in, and that's how we found our vertex. Well, now we're going to be given it in a different form. It's going to look like these. So this is the formula for vertex form, and it's called vertex form because you can take the vertex directly out of it. You don't have to do any work to get it. Okay, so the vertex is whatever this number is, and whatever this number is. So this is the x-coordinate of the vertex, and this is the y-coordinate of the vertex. So there is a minus in the formula, so you're always, the x-coordinate of the vertex is always going to be the opposite of whatever this sign is right here. Okay, that's the important part. So if this was x minus 3, the x-coordinate of the vertex would be positive 3. So the x is always the opposite of that value inside. That's the only tricky part. Okay, so if we look at number 1, the vertex is going to be, what the heck? The opposite of this. So instead of negative 3, the x-coordinate is positive 3, and then the y-coordinate would be positive 1. It's exactly what the second number is. So for the next one, what is the x-coordinate of the vertex going to be? What is it? Remember, it has to be opposite sign of whatever's in here. You got it. So x-coordinate is negative 8. Now there's nothing here. So what's the y-coordinate of the vertex? 0. Good. Excellent.
I showed 3 C's my name, idiot.
Wait, so we change the positive to negative?
Yeah, only for the x-coordinate. Only for whatever's next to the x. So because that's negative 3 becomes positive 3, but anything outside the parentheses stays. Okay, so only changing the x-coordinate to the opposite. So what's the vertex for number 3? Negative 3, comma. What's the y-coordinate of the vertex? Negative 4, good. Okay, opposite of this, and then whatever that is exactly. Number 4, you usually won't see it written like this, but because there's no parenthesis, it's because the x-coordinate of the vertex would be 0, right? That's the only way you would not have the parentheses. So if you don't see parentheses, that means the x-coordinate is 0. So this vertex would be 0, comma 1. Okay, so what's the last vertex going to be? What do you think? Bless you.
What?
Good, positive 1, negative 3. All right, so last time we had to do so much work to find the vertex.
Right.
Now we're going to get it right away. And we're also going to get the axis of symmetry. We're going to get the axis of symmetry right away because remember, it was always the x-coordinate of the vertex. So we're going to be able to graph the axis of symmetry and plot the vertex right away without doing any work for it. Okay, so let's get started. All right. First thing we always want to do, the same properties stay for this. So we want to write down if it opens up or down first. So is this going to open up or down? It's going to open up, good. Right? If this is positive up front, if there's no negative right here, it's going to open up. If there's a negative here, it opens down. All right, so the vertex. What is the vertex of this graph going to be? Right, what we were just doing. 2, comma. Good. Nice job, guys. Alright, so that's the vertex. So that means the axis of symmetry, remember that dotted line that we draw because it helps us reflect everything? That axis of symmetry is always x equals whatever the x coordinate is. So x equals 2. Okay, so those two things we automatically get, we get to put them right in the graph. So let's graph those, because that's, you always want to do those two and graph it, and graph those so you know what you're looking at to kind of start piecing everything together. So x equals positive 2, so here,
Oh, I can read by
okay, so x equals 2, and then plot the vertex. So 2 means go 2 to the right for your x, and go down 1 for your y.
2.
Okay, so there's the vertex. All right, and then just like before, now we make our t-chart. And what's the first thing that we always plug in? 0, good. Now, remember last time I said that that form was good for getting the y-intercept right away. We didn't have to work for it. In this one, we are going to have to plug in a 0, so there's a little bit of a trade-off. So we have to plug in a 0 here. And that is going to give us our y-intercept. So in parentheses, we're going to have 0 minus 2 squared minus 1. So let's make sure we can plug that in our calculator correctly. Excellent, you get 3. So here's the x coordinate, which is 0. And then we just got 3 for the y. And that is our y-intercept. Y-intercept means it crosses the y-axis at that point. So your y-intercept is always on this irregular y-axis. So I'm at 0, 1, 2, 3. Okay, so I plot that point. Then I can plot its mirror point on the other side. And I got 3 of my 5 points, so I just have to do one more. So what's a good number to pick for my last thing to plug in? There's 2 good choices. 1 would be the best, I think, because it's the smallest number. 1 or 3, because we don't know what's happening here. And we don't want to pick something too far away because it could go off the graph. So we want to pick the closest to this point right here, the vertex. So plug in 1 is the best bet. So plug it in the same spot. Zero, good. So 1, 0 is my other point. So go to the right one, and then don't go up or down at all. And then plot its reflection point. Just don't forget to connect your points and have arrows. Yeah, you just gotta wait until Maddie gets back. Yeah, Maddie. Thank you. Okay, so let's do one more. Another. Same steps now. Now we got them down. What's the direction of the opening? Down. Down, good. Oh, I forgot to do minimum and maximum last one. This is important, the minimum and maximum. It's like an important algebraic thing to know, because all sorts of graphs, and you'll see we continue graphing pretty much throughout the year. Yeah, and we have to be able to identify maximums and minimums. It's an important thing with graphs. So what you're doing is you're looking at the graph, you're finding the vertex, and you're telling if it's a maximum or minimum based on where it is. Is it at the bottom of the graph or the top of the graph? Is that at the bottom or the top? Of this U-shaped thing? Yeah, it's at the bottom, so that's a minimum. It's the lowest point on the graph. So we would say minimum, and then it's always measured by the y-axis, because that's measuring how high and low things are. So it's always that y-coordinate of the vertex would be -1. Okay, so again, you're just looking at the U-shape, and you're deciding if that vertex at the top or the bottom, and that will tell you if it's a maximum or minimum. Sorry about that. All right, so we said number 2 opens down, and that's because there's a negative out front. So we know it's going to look like this, some form of an upside down U. All right, so let's find the vertex. What do we think it is? Good, -3, 4. All right, remember it's always the opposite of what's inside, and then exactly what's outside. So that means we also have our axis of symmetry. Remember, it's always just x equals whatever the x coordinate of the vertex is. So I can graph that. And then -3, 4 puts our vertex up here. Okay, now we can make our T-chart. Once you get used to these steps, it's going to be pretty quick because this part makes it quick. The fact we can pull all that information right out. That's what took the longest on the other form. All right, always do 0 first, because that will give us our y-intercept, and we'll be able to figure out if we need 2 more points or just 1 more point. Anybody plug that in yet? -5? Yep, good. Okay, so luckily that's on the graph, so we only have to find 1 more set of points after this. So we go to 0 and then down to -5. And then we can plot its reflection point. Back there is 3, so go 3 to the left. No, why don't you go ahead when you're ready? I think they're both at the nurse. Yeah, I just realized that. Oh, good timing. Yeah. All right, so 0, -5 down here. Plot its partner point over here. And now we just need 1 more pair of points. So we have to pick an x. And we have a couple options now, because if you look at the graph, these are the x coordinates that we don't have any points for, right? You go flip up and down. So you could pick 2 on this side, pick one of the ones of these 2 on this side, or you could pick these 2 on this side. But we only need 1 more set of points to get us to 5. So what's a good number to pick? What is it? Negative? Did you say -4? Yeah, we could do -4. We could do -1, -2, -4, or -5. Any of those would work. Okay, I'll do -4. That's what we said. we're just plugging the -4 back into the original function where the x is. And that's going to give us our additional point. I think you should get 3. Yeah. Okay, so -4, and then up 3, and then it's partner point there. Okay, and then we don't want to forget our minimum or maximum. So is there a topmost point on the graph or a bottom? Right, is that vertex top or bottom?
I don't know what that, but how you said -4 and 3?
Yeah, so -4 here. That should be just the top one. That should be 4. You just did it. So that has a top. We have an uppermost point, right? The vertex is on top, so it's a maximum. And you're measuring its height, so just go over to the y-axis because that measures how high and low. So that's going to be 4. All right, we're just going to do one more together, and then you'll have the rest of the time individually to practice this. This is a good one to show together, though. All right. First thing, what direction does it open? Up, good, because the out front after the equal sign is a positive. So we open up, so it's going to look something like that. Right? It's going to be a U shape. All right, so vertex first. So what's the vertex going to be? What is it? Yes, good. So +4 is the opposite always of what's in the parentheses. And then there's nothing written after, so it has to be 0. And then that means I already have the axis of symmetry. X equals whatever the x coordinate is, so 4. Make sure you make it faster. Alright, so 4, 0, we're right here. Alright, and now we just have to plug in our numbers. So let's start with 0 so we can find the y-intercept. That 0 in right where the x is. Anybody plug that in? What do we got? You guys get 32? It should be, I think. Otherwise I'm doing front of
Yeah,
right here?
yeah.
Yeah, it's in the function.
Yeah, I guess I was
So we get 32. So you'll still get points for finding the y-intercept because that's an important characteristic of a graph. It's just we can't graph it. So this is a situation where we're now going to have to pick two numbers to plug in to get our 5 total points.
Wait, what?
Okay.
Can you repeat that? Wait, what?
So we can't graph 0, 32. So we can't use that y-intercept as a pair of points. So what's two good numbers to plug in? 3 is perfect. And stay on the same side now. 3 is right here. So don't go on the other side because you might repeat what you just found. Okay, because remember, these are partner points. So then just go one more further away. So 2 would be our other number to plug in. Okay, so let's go ahead and let's plug those in, finish up the graph, and find the maximum. Plug in the 3, you should get 2 for your y-coordinate. So our first additional point is 3, 2. But again, because the y-intercept went off, we don't have 5 points. So we have to do one more. So we plug in a 2. You gotta close out. All right, so when I plug in a 2, I get 8.
What time is class?
So over to the right 2, up 8.
Where?
And then it's partner point. Connect them. And then find the max or min. You can see, look at the vertex, and you can see it's at the bottom of the graph, right? You don't care about the arrows, you're looking for the vertex. That's at the bottom, so it's a minimum. And it's right at 0. Right? You could also look at the y-coordinate vertex. That's what's going to be your answer. So minimum of 0.